As you can see, there are ads, but they are not that common. Only one when you open it, otherwise there are no ads. On the features, you can see it has various speed measurements, including current speed, average speed, maximum speed, as well as odometer readings, such as the distance traveled this trip and your overall distance. As you can see on the bottom, there are various time measurements, moving time and idle time. It includes a compass, GPS connectivity, basically how well it can tell where you are, your altitude, and your coordinates. Otherwise, there are many other features. If we go into settings, there's a pedometer, compass, 0 to 100 meter per second reading. And now if we go into settings, you will see speed units. So you can choose between meters per second, mile per hour, kilometers per hour, knots, basically any unit you want. The same for altitude. And otherwise, just regular settings like low speed alert and high speed alert, GPS connected. And that is about all in terms of settings.
Here is some sample footage of us driving home from school. Something interesting to note here is that it takes the speedometer app longer to catch up to the acceleration of the car than the car's speedometer. It lags quite a few seconds behind. The speedometer on the car has already reached 2025 and at 2025 miles per hour, and it took the speedometer on the app a couple seconds to get up to that rate, and then again takes more seconds to slow down compared to the speedometer on the car.
I would also like to note at this point the odometer. If you had looked earlier, you might have seen that the app was already saying like 0.12 miles, while my car hadn't registered 0.1 miles yet. And as we continue looking now, for example, it's about to hit 0.2 miles, and my car has not yet reached 0.2 miles. Yep. See, it turned over at 0.23 miles. So I don't know which is inaccurate, but I would guess it is the app. So that is something to note.
In this video, we accelerate from about 0 miles per hour to about 30 miles per hour, or from 0 meters per second to 13 meters per second. We can find the acceleration with these measurements from a simple kinematics equation. The equation we use here is v final equals v initial plus acceleration times time. We know our v final, which was 13 meters per second. We also know our time, which was 6 seconds to accelerate. We also know that our v initial was 0. We started at 0 miles per hour. Then we just do some calculations, divide our 13 by our meters per second by our 6 seconds, and we get acceleration equals about 2.2 meters per second squared. Also, it is important to note that in this clip, the acceleration noted on the speedometer is kind of delayed. It's a few seconds behind the acceleration noted on the speedometer of the car. In this next clip, we test the braking and deceleration and how quickly the speedometer adjusts to that. We speed up to about 11 meters per second, or about 25 miles per hour, and then Nathan hits the brakes. The speedometer takes actually quite a few seconds to get back to 0 compared to the speedometer on the car. It takes us about 4 seconds from the speedometer to go from 11 meters per second, or 25 miles per hour, to 0. We can do the same calculation to find the deceleration here as we did for the acceleration, using the same equation, v final equals v initial plus at. Our v final being 0 meters per second, our v initial being 11 meters per second, our acceleration, which is what we're finding, and then our time, which we knew was 4 seconds from getting the speedometer from 11 to 0. We subtract 11 from both sides and then divide by 4 seconds, and that gives us about negative 2.75 meters per second squared for the acceleration.
In this example, I drove around the circle trying to maintain a speed of about 5 meters per second, or like 12, 15 miles per hour. Now we estimated the radius of the circle to be roughly 8 meters. That's including the distance we were from the actual curb. And from there we were trying to determine the centripetal acceleration needed to keep us in that circle. So, to find acceleration centripetal, we take our velocity squared and divide it by our radius. In this case, we had a velocity of 5 meters per second and a radius of 8 meters. 5 squared over 8 gave us a final acceleration inwards of 3.1 meters per second squared. Now, to convert from our acceleration to our force due to friction between the tires and the concrete, we did this equation. Mu s mg is equal to our total mass times acceleration. We can cancel out m on both sides, and we are left with mu sg is equal to our acceleration. So, then divide both sides by 9.81 meters per second squared to get mu s on its own, and we get a final coefficient of friction of 0.32. Note that it is static friction, not kinetic, as the tires are rolling on the ground, not slipping. Some of the pros of this app include the fact that it only has one ad. I wish it didn't have that one ad, but there are no banner ads, and there are no video ads that pop up while you are using the app. Second, if you're maintaining a consistent speed, it is quite accurate. I also like that the UI is very clear and easily understandable. There isn't any gunk making it confusing to read. I also like that it has many features. We did not display many of those features as they are not very useful for physics, but it's still convenient to have.
Unfortunately, this app also has a lot of downsides. One of these is that it takes quite a lot of time to update to the actual speed. There's a significant few seconds delay between the speed on the speedometer app and then the speed on the speedometer of the car. So you'll notice that the speedometer app is a few seconds behind. Also, it's important to note that the speedometer on the app will read slower than on the car, since cars often overestimate the speed for safety purposes. So the odometer is also noticeably ahead than that of what is on the car. So this also may be a problem for physics calculations that need to be very precise. Some of the other downsides is that it requires GPS and location service. It also needs to have connection to some sort of service or Wi-Fi. But if the connection is iffy, then you might have problems using the app.
As a utility app, we give it a 3 out of 5 stars. It is very versatile in that it has an odometer, a speedometer, altitude, and other things that might be useful. But its ad is annoying, especially as it happens every time you try to open the app, and it is not that precise. So if you're trying to use it for a car, maybe not the best. As for physics, we cannot give it higher than 1.5 stars. Although it can read a constant speed accurately, The second you start accelerating or decelerating, which is often used in the physics experiment, it is not very useful. We conclude that it is worse than just using your car's speedometer and odometer, as even though it may give a higher degree of accuracy in terms of decimals, it is not actually accurate to what the car is doing. Overall, this app is not very useful for physics, and I would not recommend it.